Hello everyone. Today we are going to be presenting the topic distributed file systems. In a distributed file system, files are stored across multiple nodes which can be located in different physical locations. They are also used in cloud computing environments where users may need to access files from different locations. Some examples of distributed file system are Hadoop distributed file system, Google file system, and Amazon Simple Storage Service. Why use DFS? To ensure consistency. In a distributed file system, consistency refers to the idea that all nodes should have the same view of the file system in all times. To ensure consistency, distributed file systems typically use synchronization protocols such as two-phase commit or paxos to coordinate updates across all nodes. To prevent deadlock situations, a deadlock situation occurs when two or more nodes in a distributed file system are waiting for each other to release a resource that they both need to continue their work. To prevent deadlocks, distributed file systems typically use locking protocols to ensure that only one node at a time can access a particular resource. Cache. Caching is the process of storing frequently accessed data in memory to improve performance. However, caching can also lead to consistency issues if updates to the file are made on other nodes that are not reflected in the cache copy. To prevent this, distributed file systems typically use cache coherence protocols to ensure that all cache copies of a file are kept consistent with the master copy. Thank
Let's talk about the client portion. With the use of a client portion, you can make a read and write request. For making a write request, you have to write this, and after you have to write file them. So with the use of this function, we are validating whatever input you give to the terminal. After we make a enter underscore write function call. After making this function call, code execution comes to this portion. So first of all, we are making one another function call, which is send underscore directory underscore service. So this function call, which contains RPC call to the directory underscore service. So in this file, we are just opening this CSV file, which contains all the information for a specific file, like where the file is hosted, what is the port number for that specific server, and what is the IP address for that server, which all the information stored in this file. And we just open this file and we get all the relevant information what we need, and we just reply to the client portion. After getting all this information, we want to log that particular file because we don't want a deadlock situation. So we make this function call. This function call contains another RPC call to locking underscore service.py. So basically in this section, we just check that particular file we want is locked or unlocked. If that file is unlocked, we get access permission for that file. And if that file is not unlocked, so we have to wait for 10 seconds. After 10 seconds, if we don't get a file access permission, so we get a timeout message. After getting lock permission, we wait for the content which is given by the client. So basically after whatever content client is entered, we just take that content we make another function call, which is send underscore write. This function call contains one RPC call to the file server. So file server here. After making this RPC, after making that RPC call, code execution comes here. First of all, we are just appending those all content to the specific file. So with the use of this function, this function is implemented here, and for the appending portion, we just open that file and we append those content and we return success message. And here we are make changes to the file server A, but we want to replicate this changes to the file server B and file server C. So we implement a replicate function, and this replicate function, which contains a two type of a different RPC call to the one file server B and to the file server C. And after making replication, code execution comes to the client portion, and we at the end we just cache all the changes which we made into the local cache, and at the end we unlock that particular file. So that's all about the writing portion. And so for making a reading request for a specific file, you have to write this, and after you have to write a file name. So after giving those input to the terminal, we validate those input with the use of this function, and we make another one function call, which is enter underscore read. This function is implemented in this file. So after making this function call, code execution comes here. So this is the function which we already made into the writing portion. So send underscore directory underscore service provide a specific file information, like what is the server IP and what is the server for the specific file. And after getting all this information, we make a send underscore read function call. So this function implementation which is here. And first of all, we compare file name to the file underscore version underscore map, which is one type of a container. If that file name which is stored in this which is not stored in this container, so we make RPC call to the server and we get that file, and we just return those content. And if that file which is stored in this version map, so we compare server version and we compare cache version with the use of this RPC function call, which is implemented into the server side. So here we are just returning a file version from the server side, and after comparing both the version, if both version is matched, so we just return all the content from the cache. And if both content is not matched, so we are making RPC call to the server and we just get all the content from the server here. So in the reading portion, so we just open that file and we read all the file, and we just return all the content of that particular file to the client portion. So after getting all the content, we just print that content, and if there is any changes to the specific file, so we just store those changes to the local cache, and we just print a success message. So that's all about the reading portion.
This is the server side. First, we will start the directory service. So the directory service is ready to receive, and then we will start. Okay, then we will start the locking service. Okay, locking service is ready. Then we will start three servers. First is file server A and file server B, and then file server C. Okay, so servers are ready to receive the request from the client.
Okay, so as we know, server has started. So let me run this client file. Here we can see these are the menu. From that, let me write in file 1. So this is content of file 1 that I'm writing. So now I'm ending my write request. So as you can see, write request is successfully happened.
You can see that the client 1 is connected to the file server B, and he has written line 1 from client 1 text, and we can say that the sending file version 0 is written here, and the file is successfully replicated to file server A and also file server C.
Now I am running client 2 file. These are the menus. I am appending text to file 1. Line 1 from client 2 and the write request. As you can see, write request is successfully happened.
You can see that the client 2 is also connected to the server B, and the file text is line 1 from client 2. It has been appended to the file 1.txt, and the replication of the file is made to file server A and file server C.
Here we can see previously I have written this content. So let me read file 1 again. So here you can see another content has been added by another client.
You can see that client 1 has made a read request, and the read text is line 1 from client 1, and both the lines have been read from the by the client 1.
Here I am create file 2. I am not writing here. Just check to critical section.
So let me write the file 2. Here I'm not able to write anything in the file 2 because this critical section has been acquired from the another client. So from the my side, request is continuously sent. Whenever the another client will release critical section, I'm able to acquire that critical section, and I can write whatever I want to write. Let me write into the file 2 again. Here you can see previously I'm not able to writing anything because critical section has been locked, but critical section has now released, so I can acquire this critical section. So let me write in content in this file. Let me end the write request. Let me delete the file too. So here you can see two lines, and first line has been appended by the client too. Whenever I was trying to acquire this critical section, and after that I have written this client line 2 from the client two. So you can see both line has been successfully added in file 2.
Here we can see that the file 2.txt has been made, and it has been connected by the file server A now, and the first client has written line 2 from client 2, and then another client has written line 2 from client 1, and then the reading requests have been sent over the file server A, and the replication has been made to file server B and file server C. We can also see that in the directory service, all the requests for the mapping has been made, and in the locking service, the lock granting permissions are also made.